So traditional geothermal really only goes up to about 180, 200 C, and the superhot rock is about getting that all the way up to 3, 4, 450 C as a operating temperature. If we were able to develop systems and tools that actually have that are rated for higher temperatures, we would be able to do a much better job at superhot rock developments. Our sort of long-term goal is to see 10% of global electricity being produced by geothermal energy. And today that number is, 0.3 or so percent.
Welcome to Geothermal Unleashed, where we're going to explore the cutting edge of geothermal energy. I'm Elizabeth Cambry from the Valorec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. I want to give a special thanks to Think Geoenergy. So joining me today is Torsten Kolind from Underground Ventures. We're going to talk about super hot rock geothermal and how Underground Ventures is investing in this space. And I want to give a big welcome to Torsten for joining me today. And I want to get things kicked off by starting with a question or asking you, Torsten, to share a little bit about your background and what led you to focus on investing in super hot rock geothermal. So welcome.
Thank you so much, and thanks for having me, Elizabeth. So Underground Ventures is a technology venture firm that's specialized in geothermal energy, and particularly, as you said, super hot rock. And it really comes from a point of myself and my partner in the project wanted to invest in something where we could have a real measurable impact on climate change. And geothermal is a little bit sort of underserved from the venture community. So we saw an opportunity to be the first specialized technology venture firm in this space. We launched earlier this year, so we're very new, but we completed the first 3 investments and are still learning a lot.
Wonderful. Okay, so I bet you our listeners have questions about what super hot rock even is. Can you give us a high-level explanation of what super hot rock geothermal is?
I can definitely try. So geothermal in general, of course, is about extracting heat from the subsurface and using it for either heating and cooling or electricity. Particularly for electricity, the hotter the temperature gets, the better your economics of your system is. So traditional geothermal really only goes up to about 180, 200 C, and the superhot rock is about getting that all the way up to 3, 4, 450 C as a operating temperature. So that just increase in temperature gives you 2 important improvements. One is that your liquid takes up more energy purely because of the temperature change. But the other is that when you convert it to electricity, you also have a higher conversion efficiency. So both of those are really, really useful if you want to build big utility scale electricity production facilities, power plants, and so forth. So that's the essence of super hot rock, is to get to that temperature.
Okay, that's a great explanation. So why do you think there's not more investors in this space right now?
Yeah, so I think geothermal has had this sort of weird, it's not really new, but it's also very new. We've been doing it for a long time. Places like Iceland and Northern California has a lot of geothermal energy already in place, but that's really sort of first generation traditional or hydrothermal energy. And so that space is not that new. So investment wise and venture wise, there isn't that much. It hasn't been that much interest. But there is a lot happening, now. Just the past couple of years, we have seen both Fervo Energy, which I'm sure some of your listeners are familiar with, pioneered this system where they engineered a reservoir in hot, dry rock out in the middle of the desert. There's a number of other approaches, but essentially this idea that we're moving from the less than 1% of the surface of the planet, where places again like Iceland, to really almost anywhere being able to produce geothermal energy and heat and power is really the breakthrough here. So that's why it's new. That's why venture is getting interested, but that's why you haven't seen so much of it, because they haven't really picked up that this sort of major breakthrough has happened and that there are all of these new exciting technologies out there.
Okay, so you mentioned Fervo. Do you consider Fervo to be in this realm of super hot rock of where you're investing, or are you or who are the other companies that are in this space right now?
Yeah, I think Fervo in its sort of current state is decidedly not. They are making a big point out of the fact actually that they're using existing oil and gas technologies, and I think that's sort of a de-risking part of the story for Fervo, which I really like. But they actually would like to go into hotter environments. They just got to start somewhere. They're really a pioneering force in this field that I think everyone has a lot of respect for. I do know that they would like to go into hotter temperatures, and I think a lot of others would as well. But it's a little bit of the chicken and the egg problem that we need a number of specific technologies to be improved for us to be able to operate at hotter temperatures. But on the other hand, they don't really get that chance before we start having projects that go into that hotter temperature. So there's a little bit of an interesting sort of dynamic happening in the industry right now.
Yeah, I like that. So, okay, so then for our listeners, who are companies that are doing projects in super hot rock?
So there are, the probably the most well known is Quaise Energy, which is an MIT spin out that's using a new type of drilling technique called millimeter wave drilling. And that's a way that you can drill without using mechanical force, like, the type of drill you would have in your wall at home. They're using a certain type of, it's not microwaves, it's millimeter waves, but essentially it's a non-mechanical way to drill, and that allows them to go to much, much higher temperatures. There are other companies that are doing projects that are aimed at super hot rock, but they're still in the sort of early phases. You have drilling companies, you have new developers that are looking at it, but we're getting a little bit stuck in this mechanic. I sort of mechanism I mentioned before, that they are waiting for the technologies to be ready enough. So I think you'll see a lot more come out the next couple of years for sure. But I think Quaise is probably the most well-known one.
Yeah, and I really like Quaise. So, but just to clarify, Quaise, they have drilling technology, but they're also working to develop their own geothermal,
Correct.
okay,
Yes, as
project,
I understand it, at least it's a fully vertical
right?
project where they would like to sign their own power purchase agreements and effectively develop these sites, which is really cool.
Yeah, the team at Quaise is wonderful. Okay, so when you're looking at super hot rock investments, what is the most appealing part of this from an investment perspective?
That's a really good question. I think for us, what's interesting about it, I should add that we are also okay investing in geothermal that's not super hot rock. So there are a number of other technologies that are interesting here that are not necessarily at that high temperature. But specifically, I think the idea of going to hotter temperatures and getting higher efficiency out of your systems is really mostly about allowing us to do this economically and efficiently in a lot of other places in the world. You think about, Fervo's site, for instance, is in they started in Utah. They're now in Nevada, and those are really, really good, very favorable geologies with heat close to the ground, and that's amazing. We should absolutely do this there. But the minute you get out to areas where you're either sort of have different geology or you need to drill deeper, you're going to need better efficiency of your whole system for that to be worth it to go and develop there. And I think that's kind of the opportunity for me with super hot rock, is that by raising that efficiency so dramatically, we can actually afford quite a lot more upfront cost, both for drilling, for reservoir development, for our power plants, and we can just afford to do it in places that are not as obvious, let's say,
Sure.
as the sort of west coast and the Rockies.
Okay, so let's talk about that. Let's look at the US, like where are areas for super hot rock across the US? And then let's also talk internationally. Where should we be keeping an eye out on
Yeah,
potential?
so it's kind of an interesting question. There's essentially super hot rock everywhere. It's only a matter of how deep you go. You are going to get to temperatures like, 300-400 C. So you can kind of see different maps of at what depth do you get super hot conditions. And that's really what's interesting from a developer's point of view. How expensive is it going to be for me to get to that resource? So the easy answer is pretty much anywhere. The somewhat harder answer is that there is a function of how deep you go, the geology and lithology you have in the subsurface, and your access to the rigs and the teams and machinery you need, where you can sell the power you produce. And so there's a lot of different functions that come together. There's regulatory questions that will make that work out somehow in an equation that works for a given power plant. So that's my sort of non-answer to it, is that it really is a function of depth. And right now, I think the easiest and best locations are on the US West Coast. But really, if you expand to just that sort of western half of the country, you still have pretty good geology and temperature in the subsurface to develop superhot rock. And I would say even sort of conventional or next generation geothermal also. So that's the slightly more nuanced answer.
And then when we look internationally, where would we be looking?
Yeah, so that you can start from where the current hotspots are, where you're seeing geothermal already being developed and having been developed. That's always a good starting point. Iceland, northern Italy, Kenya, Indonesia, Japan. There are a lot of places where there is just heat close to the ground, and that you have had these aquifers or water layers that have been in a sort of accessible depth for traditional hydrothermal to be developed already. That's a good place to start from. But you actually have the same sort of principle in play here, that you can move quite a bit out from those areas and still access hotter temperatures at a slightly higher depth, but much more economically than in many other places.
Okay. Okay. Could we try to walk through and do a comparison about the power output by like type of well? So if we were to take a conventional geothermal well, what would that typical power output be? Then, I mean, I've heard news about what Fervo's doing, and what type of megawatt output they're trying to generate. Then can we also compare to Superhot Rock?
Yeah, absolutely. So there's a lot of different numbers floating around, and again, they're all sort of connected, because you could have a power plant that has, for instance, 10 or 20 well pairs, or you could have it really only tied to one well. So there's a lot of different designs, and you kind of dimension it so that it fits what you need, what power you would like to produce in the environment that you are. But let's start with Fervo as kind of a good starting point. They published that they had a flow rate equivalent to 3.6 megawatts in the first sort of public. They're really good at publishing their
They are.
work. So they had 3.6 megawatts back in 2023, and they just announced that they had managed to get to about 10 in a sort of slightly different design, which is really cool. Superhot rock, and I would say conventional geothermal per well is typically around a couple megawatts or lower per well. You are really talking about whatever resource you have. You can't do so much about it. You're just trying to drill wells where that sort of makes sense. Now, superhot rock, because of those two principles I mentioned, that you have more energy per mass of water, and you also have higher efficiency at higher temperatures for your conversion, you're really getting somewhere in the range of 5 to 10x that number per well, per similar well diameter. So that tells you from a superhot rock well, we would expect, let's say, 15 to 30 megawatts per well pair, which is really quite an impressive. When you think about producing, it's a well that's the size of a pizza in diameter, right? And
Sure.
you're really producing out of a flow of steam, superheated steam that comes up. And if you're producing even 20 megawatts, I mean, that's equivalent to 15,000 households electricity consumption. It really sounds almost unbelievable that would be possible. And I think that's what's so cool about superhot rock, is that we are tapping into an enormous amount of energy in the subsurface that's fossil free, that's constant, it's base load power. It has no issues with people, living close to it. It really is something that, in our view at least, is almost unbelievable, and we're really proud of hopefully moving forward that field.
Sure. Okay, so we're going to get more power output, but one thing that we haven't talked about is how does that impact the levelized cost of electricity, say going from conventional EGS then to super hot rock? I would imagine it's going to significantly reduce the levelized cost of electricity.
Yeah, it will, but of course you also expect the deeper you go, that you would have higher capex, higher upfront costs from these systems. You might also have more expensive surface equipment. Depends a little bit on how your turbines are being made, if they need to be coated or built in sort of different ways. So yes, you have higher efficiency per well, but you may also have higher costs. So it doesn't translate into, let's say, a 5 or 10x better LCOE here, but significantly better. And I think that time will show exactly how much. The Department of Energy has their sort of long-term goal at $45 per megawatt. And I think that is not assuming super hot. That's sort of assuming general improvements in the space with scale and learnings and so forth. And I would definitely expect super hot rock, once it's fully commercialized and in operation, to be below that number.
Okay.
So,
I,
but
I like
time
that
will show.
answer. Okay, that's good. Okay, so let's talk a little bit about the companies that you've invested in, if you can speak about them.
Yeah, absolutely. So as I mentioned, we started earlier this year, so we are very new. But the first investment we made was in a drilling company called GA Drilling. And what they are doing is sort of long-term, they are pioneering the field of plasma drilling, which is a little bit of a variant of quays that I mentioned. It's sort of a non-mechanical, high temperature ready drilling system, but much more sort of here and now. They have a really cool product called Anchor Bit, which is about how you anchor the drill string downhole, and how you're able to, by stabilizing it, either drill further, particularly when you're doing horizontal or almost horizontal drilling, or more complex drilling situations. If you're able to stabilize and anchor the drill string, you're getting a lot of wins out of that. So that's really cool, and really happy, proud about that what the team has done. So that's GA. The next investment was in a company called Canopus Drilling, and they are doing, it's also a drilling company, but they are doing particle drilling. So this is about where you essentially, through a jet in the drill head, you're jetting out very, very small steel particles that helps to sort of pulverize the rock before the normal drill bit goes in and does the mechanical work. So it's a hybrid approach that allows you to drill faster, cheaper, and in a sort of a much simpler way than plasma drilling. You can just do it with existing drilling rigs and strings and systems, which is really nice. Yeah, and they're coming out of the oil and gas industry, and really solid group of people behind that company, Canopus. Third one we just closed. It's unannounced, so I can't tell you quite yet which one it is, but a Houston-based company that's focused on higher temperature downhole tools. And this is kind of an interesting also aspect of this chicken and the egg problem, right? Where we can drill today to any temperature. We have drilled wells into 400, 450 C. But the problem is that there's a lot of other things we can't do. For instance, we can't really operate with sensors at that temperature. We'd have to really cool the mud flow and probably have insulated drill pipes and never stop the flow. It's very complex to use electronics and sensors at that temperature today. So if we were able to develop systems and tools that actually have that are rated for higher temperatures, we would be able to do a much better job at super hot rock developments, and that means faster and cheaper upfront costs. So really cool. There's a team, multiple people working on that, but also really happy with that most recent investment.
Okay, so you mentioned some technology gaps aside from drilling. But when you're looking at making an investment in technology for super hot rock geothermal, are there any technological factors that you prioritize? when you're making investments or looking at technology?
Yeah, I think um, it's the easiest way I can answer that is that we're investing into a future where we believe that there's just a massive growth of this the field of geothermal energy in general and super hot rock geothermal in particular. And so our sort of long-term goal is to see 10% of global electricity being produced by geothermal energy. And today that number is, 0.3 or so percent. And so 10%, it may not sound like a lot. It's kind of similar to where wind is at today. Solar is about 6-7%. So it's sort of on par with other renewable sources. But 10% of geothermal energy, if we were to get there, we would talk about thousands of power plants and possibly tens of thousands of wells. So it's an enormous feat to get there. So when we look at technologies for that future, we're really looking for what are the products and technologies that can de-risk this for everybody else. We're not necessarily looking at the ones that do it all themselves, the sort of vertically integrated, one power plant after another, but much more so those that can be part of a global toolbox. Let's say that, put it that way, and say that these are the bits and pieces people choose from when they decide we're going to do a new geothermal power plant, a 100 megawatt geothermal power plant in Indonesia. Well, what do we need for drilling? What do we need for well casing? What turbines do we need? All of that stuff, we're hoping to invest into those companies that can allow everybody else to succeed with their ventures. And that's just essentially a choice, a strategy. We believe we'll have higher impact that way. But obviously the alternative would be to invest in vertically integrated companies.
Sure.
So
Yeah.
it's just a choice that so far I feel really good about.
Yeah, and I resonate with that. I agree. I like that approach. So, okay, I'm going to say this, and correct me if I'm wrong, but Underground Ventures is one of the very first investors in this space. Is that a correct statement?
That's correct. Yes.
Okay. So then that being said, do you feel this immense pressure being one of the earliest investors?
Honestly, yes. Like, I'm not gonna lie. There are a lot of people watching us, and it's interesting. Of course, there's a lot of people from the geothermal industry because we're the new kid on the block. So that's just kind of interesting. But there are even more from outside of the industry. There's a lot of people from venture capital, energy funds, climate funds. There are people from more traditional finance that are looking. And I think they're just kind of curious about who are these crazy people who would put all of their money in one basket of saying this is all geothermal, because we really are the first ones to do that. And so that places a certain amount of responsibility on your shoulders. We have to, first of all, of course, make some good investments, but we also have to behave like good people. We have to. We're building a brand for venture in general here, and I think geothermal. When you talk to founders, especially technical founders, they have been sort of burned a little bit by venture capital in the past because they feel like they're building something that's really impactful and they have some really, really amazing technical solutions. But venture capital always had reasons for why it was not a good fit. Like come back later, or come back when you have the first big customers, or come back when something, they never say no. So I think we have a responsibility on both sides here to the community to make sure we take people's projects seriously and evaluate their technologies diligently, but also to the rest of the financial world that we need to show that geothermal is in fact ready for venture capital and for more serious, very large sums of money coming in. So yeah, there's a lot of eyes watching us for sure, but I don't know. So far, I feel good about it. I feel like it's going well, and we're getting good input, but it is a lot of responsibility. I think that's a fair question.
Great. Okay, so you said that you've been in this space for about a year now,
Yes.
correct? Okay. So that you probably have had just a whirlwind of learning everything geothermal. And the geothermal industry I have found it's just full of wonderful, very nice people very welcoming, very warm. It's very easy to get engaged and to learn because everyone wants to see this industry grow. And so they take their time. But what are the key things that you've learned, or maybe you made assumptions early on and you found, as you've learned more about the industry, um, maybe your assumptions weren't correct. What were your key findings this
Yeah.
year?
Yeah, that's a good one. I think I first of all, I totally agree. I felt very, very welcome. I felt like people, because I have been on a learning journey. I think we started a year ago, but I got into the field about 2 years ago, and thankfully I have a technical background, so I felt in a good place, sort of starting to learn about the bits and pieces of technology here. But people have been very patient with, explaining how things work and bearing over with the fact that I didn't know everything in advance and weren't sort of an industry veteran. So that I agree with that part. That's been really, really good. Um, I think the sort of when you asked about assumptions that were right or wrong, um, I definitely very quickly had the assumption that this was a field that was dominated by oil and gas knowledge and talent and experience. And I think that that is definitely true, but I have found that it is both good and bad. I think,
Okay.
because you have a wealth of experience in this field. You have all of we have drilled so many oil and gas wells. We know so much about the subsurface. We know about risks. We know about how to complete our wells. It's just an enormous amount of risk that this new field doesn't have to take. And that is, I think, has pushed us forward much faster than what otherwise would happen. However, it is also that same experience and that same background also leads people to believe that you can't do it in other ways than we used to do in oil and gas. So it really goes both ways, and it's so interesting. I find that whenever I hear about new, radically different approaches in this industry, new products and technologies, almost every time there's something that's really, really new, it's a non-oil and gas person who has invented it.
That's
And that
interesting.
doesn't mean we don't need that whole side of the experience to develop it, but it's interesting how much that locks people into the constraints of what oil and gas knowledge and equipment is able to do. So it's a double-edged sword. It's incredibly valuable to have that experience, but you have to be very aware of not falling into the trap that geothermal can do nothing differently than oil and gas.
I I really like that because I never thought about it like that before. So, okay, when we look at super hot rock, we are going to be taking oil and gas techniques in super hot rock.
Yeah.
And then can you give some example? And I think you have throughout this, but maybe you can restate, like we're going a step farther from oil and gas techniques, maybe in the drilling space. And so I think that's what you're alluding to is you're taking technologies that are being developed from non-oil and gas people, and that's going to be critical for us to actually execute the super
Yeah.
hot rock.
Yeah. So the easy example is drilling. Absolutely. We have never really needed to drill more than about 180 C for oil and gas exploration, because it's just typically closer to the surface. So there hasn't been a need in that industry to develop both technologies and tools and processes for those temperatures. That doesn't mean you can't do it. It's just that is what we get for free by just reusing what they have. And so no reason not to start there. That's why Fervo exists and why that's really, really good. But going into hotter temperatures, it's so first of all, the drilling piece, while again, we can drill to hotter temperatures, but we have also things that we didn't think about. The fact that if you have sensors around them, they might melt, or if you have a battery, it might not work at that depth. Remember, if you drill deeper to access higher temperature, you're also getting higher pressure. So now all of a sudden you could have issues with pressure that will not either your tools will not withstand, or your well completion eventually for production will not withstand. So the sort of tooling around drilling is important for higher temperatures. And then I think the piece that's sort of indirectly about higher temperatures is that you often have to go further to access them. So because you have to go further, drilling tools that are optimized for harder rock types or being able to drill further all of a sudden are a lot more useful here. So that's not directly about higher temperature, but it's about getting to a higher temperature
Sure.
that makes a whole category of drilling tools all of a sudden relevant, even though oil and gas hasn't had to do that. And I think for well completion, super interesting space. Once you have you obviously know all this, but in case people don't, once you have drilled and you want to get your well ready for production, you have to case it. You lower casing strings, typically these sort of stainless steel tubes down. You cement them in place. You connect them. All of this is very well known from the oil and gas industry, but higher temperature, higher pressure, and because we might cycle the temperature and pressure also, it puts an enormous amount of stress on your well completion. So how do we then take those technologies and either improve them sufficiently to perform at higher temperatures, or how do we think out of the box and say, what if we had to come up with something today that would be a solution to that? Would we really just take oil and gas and fiddle with it, or would we come up with something new? We're often faced with that question when people have new designs. Are they building upon oil and gas to incrementally improve, or are they actually suggesting something radically new, which of course is much more higher risk?
Sure.
So we have to figure out, even if it's a better solution, is it okay to take that risk? Welcome to the world of a specialized venture capitalist. That's
100%.
very much what it's all about.
Okay, so I want to just ask just a few more questions. First, where are you scouting for technology? So obviously, I've seen you all around the geothermal space and touching into the oil and gas space, but are there other spaces that you are scouting for technology that might have application here?
Yeah, so we have been going to the same events. Clearly, it is still not a huge space, so that has been, I think, fairly uncomplicated for me to get into meeting a bunch of the people already in the space. That is really useful for scouting, but also for validation. Because I can source a lot of opinions about somebody's new technology, and I should say it's very common that I get negative opinions. It's much easier for somebody to tell me why something is not going to work than it is to explain why it would work. And so that you always have to handle to what level are you okay with negative opinions. They're really, really useful because there's a reason
Interesting.
behind it. So just letting you know, yes, it's good for scouting. Yes, it's good for validation. But I think the more you're looking to solve problems that the industry has not solved yet, the more you have to go to other sources. And for instance, I think we don't have the capacity yet, but I'm hoping we will have the capacity to go out into more sort of general scientific communities like material science, mechanical engineers, folks that perhaps are working on something useful for geothermal but didn't know that.
Sure.
If you have a new type of cement for casing, or you have a new type of polymer for O-rings in a system, right? You may not know that that's relevant to geothermal. So how do we go and get those people interested and give them the sort of basic intro to the space that will make them feel like this is worth their while? Because that's very much what it is. You have a choice when you're a technologist. Where do I go with what I have built? So that I think is much more in the future where we're going to source.
So you know what I found was interesting at one of the Super Hot Rock conferences that I believe we were both at earlier this year, there was some folks from the nuclear industry. I don't know if you noticed that. And
Yeah,
is
yeah.
do we are there synergies to where we could be leveraging um any of the experience from the nuclear industry for Super Hot Rock?
Yes. Ooh, I love that. Yes, there is. Partly because nuclear, of course, is also energy and power production. So that's the same trade. It's baseload power. It's fossil free. There's a lot of parallels just in the industry and market that nuclear is in. But nuclear, as you sort of hinted towards, also has other parallels. They deal with higher temperatures. So that whole like 200 C up to 400 C, a lot of people in nuclear are like, yeah, that's what we do every day. They deal with corrosion. The higher temperature and pressure your water is, particularly if it moves into supercritical state, becomes very corrosive. So how do we deal with that in our well completion? How do we deal with it in our turbines? These people have a lot of knowledge in that space. They work with molten salts. Could we use that for geothermal? There's a lot of parallels where we ought to look for what they have learned. I think there's also a sort of an interesting their space in society because nuclear has been, I wouldn't say around for longer because geothermal has also been around for a long time, but all of the new technologies in nuclear, there's a lot of stuff that really has had a lot of skepticism and that people over time have warmed up to and we've gotten better at. And so geothermal also probably is going to go on a little bit of a similar journey, super hot rock in particular, where there'll be a lot of questions in the beginning that later on will be sort of, oh yeah, obviously that seems reasonable. It's heat in the ground. Why don't we produce power from it? So I think there's a lot to learn from the nuclear journey. And maybe the last thing I'll say, this is a super interesting topic. What new nuclear has been really successful with is to modularize things.
Okay.
So they're saying, hey, I know we used to build these massive nuclear power plants back in the day. Nuclear 2.0 is container based or modular or small and can be transported easily and you can kind of mass manufacture them. Wind is the same, solar is the same. Geothermal is not because it's highly dependent on geology and the heat you have and you know this whole the toolbox I mentioned before. But I think we need to learn from nuclear in how do we to the greatest possible extent modularize this space so that the investment markets understand that yes, if you can produce one tomorrow and I give you a lot of money, you can produce 1,000 tomorrow. Like that sort of rapid increase is a lot easier to understand with a gigafactory, to use a Tesla term, than it is with a developer of geothermal in different countries. You can almost hear it, right? What is the more investable path? So that's another piece I really want us to learn from it.
Yeah, that's extremely interesting. I hadn't considered that before. Okay, so I want to ask one last question. For startups that are looking for investments, what advice would you give to them?
Uh, Fundraising is always hard. You know, I was a founder myself for 10 years, chronically underfunded. I hated fundraising. It was the worst thing on the planet. You had to, please all these investors' egos. So I come with a lot of empathy into this space. And I think what I learned too late, essentially, in my founder journey was to not waste my time with investors that are not going to invest anyway. So go in and try to understand what do these people, what do these investors care about? What have they invested in the past? How early do they invest? How technology driven are they? Are they like us, investing in the picks and shovels of the industry, or are they investing in power plants? Are they investing in there are geothermal investors that will invest in software. That's totally fine, but that's a totally different game than doing a drilling hardware technology. So, understand what your investors have invested in the past and how likely they are to invest in what you have now is really, really, really important to not waste all your time with the wrong people. Venture capitalists love taking meetings and they love not saying no. Even though we have to say no to 9 out of 10, if not 99 out of 100 cases, we hate saying no because all of a sudden you turned out to be the next big thing. And then we don't want to have said no. We want to come back and say, oh my God, please take my money. And that really is just driving founders crazy that we're so bad at saying no. We always say, oh, come back, can you do this spreadsheet for me or this projection or whatever we ask for, right? And it's just free labor. It's like, of course you can, but you have work to do. So I feel a little bit, I think Joachim, my partner in this, is also very touched by our founder experience of like, we have to respect founders' time and not just ask them for all sorts of stuff and totally fine if we're not the right investor. Let's not all waste our time here. That's at least some of the things I would do as a founder before spending too much time on investors. Understand how likely this is to work out based on their record.
Sure.
And focus your time on those that are likely to work.
That's great advice. Well, I want to thank you so much, Torsten, for joining me today. You're definitely in the hottest sector of geothermal. And I want to thank our listeners for joining us today on this episode of Geothermal Unleashed. I hope today's discussion has sparked new insights and deepened your understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.